You can go ahead and get out your demonstrating the states of matter notes and follow along. I'm going to first go over the properties of a solid. Some of the properties of a solid include the fact that atoms and molecules are very tightly packed together. There is no set structure in a solid. There is definite shape. Okay, so you can definitely see the shape of anything that's a solid. There's cooler temperatures. I think back to the example of water. In solid form, it is ice, which is obviously very cool. Then finally, this is a fourth one, but there is very little energy in a solid because those atoms and molecules are so tightly packed together. They don't have a lot of room to move. Therefore, there is very little energy in a solid. Look over here at a liquid. In a liquid, the atoms and molecules can flow a little bit more easily, more so than a solid. Another important thing here is that the volume in a liquid does not change, okay? But it can change shape. Volume does not change, but a liquid can change shape. There is no set position. Okay, it kind of depends on the container that the liquid is in. And then finally, their temperatures are warmer than a solid. And the energy is slowly increasing from a solid as well because those atoms and molecules have a little bit more room to move. Let's move over to gases. In gases, the atoms and molecules are very widely spaced. Okay, you will see shape change and volume change in gases. Shape change and volume change in a gas because there is no set structure. The atoms and molecules are free to move about. And then finally, well, several more things. One, temperatures are going to be warmer in a gas than they are in a liquid. Remember, with that temperature increase, we also have energy increase. The energy becomes very high in a gas because those atoms and molecules are able to move about very quickly. They have more energy. If we look at down here, the most common example of matter is water. Okay, in solid form, water is ice. Liquid form, as temperature rises, as energy increases, it is water. And finally, once again, as that temperature begins to increase and energy increases, we have water vapor. Let's take a look at solids here. Right here under solids. Solids are characterized by the set placement of atoms and molecules within the structure. That's why there is set structure, definite shape in a solid. The only movement that occurs is the vibration of the atoms or molecules in place. They do not move, but they're just able to vibrate. And due to these characteristics, solids have definite shape and definite volume. Okay, volume does not change, shape does not change, and therefore the particles will remain in place. In a liquid, atoms and molecules in liquids do not have a set position. Okay? The bonds between the atoms and the molecules are weak enough that constant movement, that flowing easily, is present within whatever substance we're looking at. And this allows liquid to change its shape based on whatever container you pour it in. But still, you're going to have that same volume. The volume does not change. The shape may change, the volume, what's inside, does not change. Now this up here is for gases. I should probably put gas. Okay, because the molecules and atoms are spread out, there is a great deal of energy in gases. Okay, there's a great deal of energy, there's a great deal of movement, and there's a great distance between these particles. So in a gas, we have a lot of energy, a lot of movement, and a lot of distance between these atoms and molecules. Also, they have even more energy than either solids or liquids. We have the most energy in a gas. Well, besides plasma, but we'll get to that later. Okay, gases have a lot more energy than solids and liquids. And then gas atoms and molecules are usually very spread out. Again, that's the distance. And there is no set position. Once gas molecules and atoms are free, they will spread out as far as physically possible.